Okay, today we're going to be doing the different types of differentiation. So to start, we're going to do the constant rule. So the constant rule states that the derivative of any constant, which we'll list as c, will be equal to 0. So an example of this would be if you wanted to find the derivative of, let's say, y is equal to 6, y prime is equal to 0, no matter what number it is. Even if we have z is equal to a very large number, like 1000, the derivative of z will still be equal to 0 because of the constant rule. Next up we have the power rule. So what the power rule says is that if we take the derivative of any variable to the power of n, our new derivative, or our answer, will be n multiplied by our variable x to the power of n minus 1. So an example of this is if we have y is equal to x cubed. If we take the derivative of y, what we're going to do is we're going to drop this 3 down up front, and we're going to subtract 1. So now it will become 3x squared. Another example is, let's say we have z again is equal to 4x, let's say to the 4. So this is a constant, so we're going to just keep it outside. So this is a little different than the constant rule. With the constant rule, we would assume that this goes to a 0, but since it's attached to the x, we just ignore it for now and it'll come back later. But let's say we add 4 to the end. When we have the derivative, the plus 4 will be turned into 0, so it'll go away. And what we'll do is we'll bring the 4 down, so this will become 4 multiplied by 4 multiplied by x. We subtract 1 from the exponent, and that'll be 3. So our z prime will equal 16x cubed, and our 4 will go away. Next up we have the chain rule, and this is where it'll start to get a little bit more complicated. So what the chain rule is saying is we'll have some sort of function inside of a function. So what I mean by that is if we have cosine, and let's say we have 2x on the inside. So our first function will be cosine. So we'll label it, our f is going to be just cosine. And our g is going to be 2x. So we can see here, this is an easy one, we can see that there's a function inside of the main function. So another example of this would be if we had, let's say, ln of 4x. So our first function is the ln function. However, there is something inside the brackets there, which is the 4x, which is our function, which is inside of our other function. So these will be our two examples. So let's say we have f is equal to cos of 2x. So to start, what we're going to do is we're going to have f prime. So we're going to take the derivative of cos x. And the derivative of cos x is going to be negative sine. And then we have to take the same, as it says here, you take g of x and you drop it down and keep it the same. So we're going to have negative sine 2x. Now, here's where we multiply it by the derivative of the inside function, which is our 2x. So that will just become, that will become 2. So our function will now be negative 2 sine of 2x. Okay, so now for the second example, we have z is equal to ln of 4x. So to start, we're going to have the derivative of the outside function with the inside function staying the same. So our f prime is going to be the derivative of ln, which is going to be 1 over x. But since this one's a little tricky, the derivative of ln is 1 over x. But since we're doing the chain rule, our g of x is going to be the denominator of our function. So instead of 1 over x, we're going to have 1 over 4x. And now we're going to multiply it by the derivative of the inside function, which is our 4x, so it will be 4. So we'll get 4 over 4x, which could cancel out, which gives us 1 over x anyway. Next up, we have the product rule. So what the product rule is we're going to find the derivative of two functions when they're being multiplied together. So an example of this would be if we had x cubed multiplied by cos x. So we're going to label this f, and we'll do this as our first example. So according to the product rule, what we need to do is we need to take the derivative of our first function multiplied by our regular second function. So what we'll do first is we're going to label this. So this will be what's known as our f, and this is what will be labeled as our g. It doesn't matter which one you want to label as your f and g, it's just easier for right now to go in order. So to start, we're going to take the derivative of x cubed, and if you notice, this is going to be the same thing as our power rule. So what we're going to do is we're going to make this 3x squared, so that's our derivative of f prime at x. So now we just multiply it by cos x, because that's what our g is. Now we add our regular f of x, which is our x cubed, and now we multiply it by g prime, and our g is cos of x. So now that's going to become the derivative of cos, which is sine of x. So to make it a little bit neater, what we're going to do is we're going to call it 3 cos x squared plus negative sine x cubed. So now we're going to do another example where z is going to be equal to, we're going to do sine of 3x. We're going to multiply it by 5x squared. So our first step is going to be labeling. So this is going to be known as our f, and this is going to be known as our g. So our first step is going to be taking f prime. So as you notice, this is in the form of the chain rule. So first we're going to take this and copy it over here. So we're going to put sine 3x. Now, ignoring the product rule for now, because this is, we're going to just work with the sine of 3x. So we know that this is our outside function, which is the sine, and we know that the 3x is our inside function. So what we're going to do from here is we're going to take the derivative of sine, which is cosine, and if you remember from the product rule, you copy what's inside the brackets over, and you multiply it by the derivative of the inside the bracket, which will be 3. Now, that's the derivative of our f. So we multiply it by our regular g, which is our 5x squared, and we're going to add our regular f, which is sine 3x, and then we're going to multiply that by our g prime. So our 5x squared is just going to be our power rule again with the constant out front. So I'll put it up top here, just like the sine. We have our 5x squared. Since our constant is connected to our x, we can just take it outside for right now, and we'll put it in after. We're going to bring down the 2. So it's going to be 2 multiplied by 5. We're going to subtract the 2 by 1. So we're going to get 10x to the power of 1. So to clean this up a little bit before we switch pages, we're going to make it so that this becomes 3 multiplied by 5, which is 15. So 15 cos of 3x multiplied by x squared, and then plus 10 sine of 3x multiplied by x. So our final rule is the quotient rule. So what the quotient rule says is the derivative of some function f divided by some function known as g is going to be equal to the regular function of g multiplied by the derivative of f minus the regular function f multiplied by the derivative of g, all divided by g squared. So an example of this would be, let's do 2x to the 6 divided by sine of x. Not too bad. So to take the derivative, we're going to make y prime. So what we're going to start is we're going to label our f and g. So we know that whatever's in the numerator is going to be our f, and whatever is the denominator is going to be our g. So to start, we're going to just write out sine of x, and then we're going to multiply by the derivative of f. So we're going to speed this up a little bit, because this is just another example of power rule. So we're going to bring the 6 to the front, multiply it by the 2 to get us 12x, and then 6 minus 1 is 5. Now we're going to subtract regular f, which is 2x to the 6, and we're going to multiply it by the derivative of g, which is going to be cos of x. And we're going to divide this all by g of x squared, which is going to be sine of x squared. So another example of this is we're going to have cos, we're going to do 4 cos of 3x divided by, we're going to make that set, divided by, we're going to do ln of 2x. Make it a little tricky. So to start, we're going to look back at our rule, and we have the regular g of x multiplied by f prime at x. So we're going to label, so we know that this is f, and we know that this is g. So for our prime, what we're going to do is we're going to take our regular g, which is our ln of 2x, and we're going to multiply it by the derivative of f. So now this is a little bit of a tricky one. 4 cos of 3x. So since this 4 is with a function and not being added, we can ignore it for now and just work on the cos 3x. So now if you notice, this looks like our chain rule. So this is going to be our minus sine of 3x, and we're going to multiply it by the inside of the brackets, which is going to be 3. And now we can bring down the 4 and multiply it all by 4, giving us negative 12 sine of 3x. So we'll put this into our equation up top, sine of 3x. Now what we're going to do is we're going to subtract the regular f multiplied by the derivative of g. So our regular f is just 4 cos of 3x, and our new g is going to be the ln of 2x, which we'll do right beside our cos. So ln of 2x. So this is another chain rule. So if you remember from from the questions before, our ln becomes 1 over x, but because there's a 2x here, that has to go in the denominator, looking like that. And now we multiply it by our inside function, which is the 2x, which will just become 2. The 2's will cancel, and it's just 1 over x. So multiplied by 1 over x. Now we divide it all by g squared, which will be ln of 2x squared. And that's our derivative of z. So finally, what we're going to do is we're going to go over a couple of special cases for things that will be tricky, such as e the exponential function. So what the exponential function is the derivative of e to the x is e to the x. It's itself. The reason for this is because e is just a number. There's this formula that's a to the power of x. If you want to take the derivative, it's going to be a to the x ln of a, assuming a is just a constant number. So what we can do here is, if we use e to the x here, we know that e to the x will keep the same, but ln e, they actually cancel each other out, which is the reason that we have e to the x. But if we want to use this equation any other way, let's say we have 3 to the x, this will become 3 to the x ln of 3 with absolute values. So we're going to do one example here with all of them and make it nice and tricky. So we're going to have e to the x, we're going to go plus 3 to the 2x, and we're going to do that multiplied by 4x. So whenever you see a plus sign, that means you can split them up and do two different derivatives. So we know that the derivative of e to the x is just e to the x, so that's all done. So now we say plus. So if you look here, this looks like a function inside of a function. So we know that we're going to have to do the chain rule. So to start, we're going to take the derivative of the outside, which is the 3, to the x, we're just going to use this formula right here. So we're going to have 3 to the x, but it's going to be 2x, and we're going to have ln of 3. But now we have to multiply it by the inside function, which is our 2x, which will just become 2. And since this right here, we'll use our product rule because it's two functions being multiplied by another, we have to multiply that by 4x. And now what we're going to do is we're going to add the derivative of 4x, which is just 4, multiplied by our regular first function, which is the 3 to the 2x, giving us the long derivative of e to the x plus 3 to the 2x ln of 3 multiplied by 8x plus 4 2 multiplied by 9 to the x.